Hi guys, until now we looked at the different topics in data mining at a high level. From now we're going to go into details of them. We are going to look at our data a little bit more in this video. This forms the second half of our first chapter. Before we dive into the topic, let me give you a brief overview of the different subsections that we have here. First, we're going to discuss about the attributes and the fields that make up our data. Then we're going to learn about some statistical descriptions of data, which will help us summarize the data. Then we're going to learn about some visualization techniques which will help us visualize our data. Then we'll learn how we can compare two data sets and see how similar or dissimilar they are. Let us now learn about data objects and attribute types. The notion of data objects and attribute types can be better understood with the help of a table. Now in a table, you usually have rows and columns. So where do data objects and attributes fit in here? So data objects are like your rows and attributes are like your columns. If you guys remember your relational database management systems where you had tuples and attributes, just like that we have data objects and attributes. And attributes are the ones that describe a data object. Now attribute is the name that we give in the case of data mining. In the case of machine learning, the name changes to features, and few other fields call it as dimensions or variables. They all relate to the same thing. Now you need a set of attributes to describe one particular data object. So this set of attributes is called as an attribute vector. So let us take a small example here. Let's say that you have a database which records all the employees in a company. And let's say Sam is an employee. So this guy will be my data object. So let's take a different pen. Okay. So this guy is my data object. So what are the different attributes I can use to describe Sam? I think that's fine. So let's say Sam has an employee ID. Let's say it is some 13. Let's say he works in a department whose ID is 2. And let's say his salary is 10k. And what else? You can even add the bike that he rides. I mean, it is unrelated, but you can still add it. Let's say he has a Hero Honda. So if you look at this data here, so all of these are your attributes. So these are all your attributes. So if you look at this data here, it's not homogeneous. So what do I mean by homogeneous data? Where you have similar kind of data. Here, every attribute is different. Even if you have numbers here, the numbers present here are all of different types. For example, this number 10,000 does not share the same properties as this number 2. Now why do I say that? Now you can compare this 10k with another number, say 20k, and then say that 10k is less than 20k. That does make sense. But you cannot compare this 2 with another number 3 and then say that 2 is less than 3. Why so? Because 2 here represents department ID. It is not a number. It does look like a number, but it doesn't share the values or the properties that my salary takes. So even among numbers, you have different kind of properties here. So to help us better understand these properties, we're going to learn about the different categories of attributes. First up, we're going to learn about nominal attributes. So what are they? Nominal always refers to anything that is related to names. So usually they are used to describe categories. So let's say you have an attribute called as hair color, and then you only know that there are finite number of colors. So each of these colors will form a category. Like blue is a category, red is a category, green is a category. Similarly, you can have another attribute called as marital status, where single and diverse are your categories. Now, you can also use numbers to represent these categories. So you can say that blue can be represented by 1, red can be represented by 2, green can be represented by 3. If you guys remember enumerations from C programming, these share a similar property to them. These numbers, they share a similar property to them. So even though they look like numbers, you cannot essentially perform any arithmetic operations on them. The previous example that I took pretty much explained that. Now, I haven't explained the notion of mean, median and mode, but just for now, do remember that you cannot calculate mean and median over them, but you can calculate mode. These will be explained in the next subsection when we are going to deal with statistical descriptions of data. The next kind of attribute we are going to look at is a binary attribute. Binary attribute is not entirely a different kind of attribute. It is just a subtype of our nominal attribute. In our nominal attribute, we can have n types of categories, whereas in binary attributes, you can only have a couple type of attributes. So usually there are zeros and ones. If your binary attributes take the values true and false, they are called as Boolean attributes. There are few more subcategories in binary attributes. Let us see what they are. First up, we have symmetric attributes. So in symmetric attributes, both the values that your attributes take have equal weightage. So for example, if you consider the attribute gender, it can take the values male and female. So over there, male or female, they don't have any kind of deviancy. That is, you cannot weigh male more than female or weigh female more than male. Both of them have their own weightage. So over here, you call this attribute as a symmetric attribute. Just like symmetric attribute, we have asymmetric attribute. Over here, one of the categories have a higher weightage over the other one. For example, if you consider an attribute called as cancer test, usually when we perform a test, a medical test, we are really interested in the cases which are positive. That is where someone has a cancer. So here we definitely are showing some kind of bias towards one of the values. So if we have an attribute like that, then we'll call it as an asymmetric attribute.